So in today's lesson, you're going to learn about another quality of a quadratic function's graph. Remember, that's called a parabola. It can be a positive parabola if it has a minimum point and it would continue upwards. It could be a negative parabola if it has a maximum point and continues downwards. So today you're going to see that not only can you find what's called the vertex and the axis of symmetry by the graph of a parabola, but you can also find what's called the roots. And the roots go back to something that we have solved for before when we were solving quadratic functions. So now you're going to see that when you factor an equation, you find what's called the zeros for the quadratic function, which is also called the roots for the quadratic function. So let's remember what it looks like to factor. So if we have number 1, and I was factoring this, I would remember that I need 2 factors of 10 that have a sum of -7. So that would be obviously -5 and -2. I would factor by grouping. So it would be x squared minus 5x minus 2x plus 10. And that would be x times x minus 5 minus 2 times x minus 5, which winds up being x minus 5 times x minus 2. And if I would solve that, I would get negative or positive 5 and positive 2 as my solutions for x. And it's set equal to 0. So you can think of it as the zeros of the quadratic function. Number 2, same idea, same step. I would look for my factors of 9 that have a sum of -6, and I get -3 and -3. And again, factor by grouping. 0 equals x squared minus 3x minus 3x plus 9. So 0 equals x times x minus 3 minus 3 times x, it should be plus 3, times x minus 3, which gives me 0 equals x minus 3 times x plus 3. And those, again, if I were to solve, I'd get positive 3 and -3. So they're the zeros of the function, which we're later going to see are also called the roots. Number 3, we would do it one more time, same process. We have -3 as our product, so we need 2 numbers that are factors of -3 that add up to -2, so that would be -3 and positive 1. Factor by grouping. 0 equals x squared minus 3x plus 1x minus 3, which gives us 0 equals x times x minus 3 plus 1 times x minus 3. So my linear factors, or my zeros, would be equal to x minus 3 times x plus 1. And if I were to solve that, I would get positive 3 and -1. So let's see how that is related to a graph. If we replace 0 with y, we would have a quadratic equation with an infinite number of solutions, but the solutions found above are called the roots. We can find the roots of these equations by graphing. They are also called the linear factors. They are also called zeros, the zeros. Okay, and those terms are used interchangeably. You need to know that roots are linear factors are zeros. So find the roots of each quadratic function by graphing, then write the linear factors of the function. So we're going to do this a little bit backwards. We're going to factor, graph it, and show how all those parts are related. So if we take a look at this first one, and I'm only going to do one example with you, and then you're going to do the rest on your own. We have y equals x squared plus 6x plus 5. So right away we can start by factoring. We need factors of 5 that have a sum of positive 6, so that would be 5 and 1. So this would be factored as y equals x squared plus 5x plus 1x plus 5. Then by grouping, y equals x times x plus 5 plus 1 times x plus 5. So we have y equals x plus 5 times x plus 1. So these two equations are equivalent to each other, y equals x squared plus 6x plus 5, and y equals x plus 5 times x plus 1. If I were to solve these and had it set equal to 0, my zeros would be -5 and -1. So let me show you how that works out in the graph. So if we go to our graphing calculator and we type in the original equation, y equals clear anything that you already have in there, and we write in x squared plus 6x plus 5. Pull up the table, and we go up to -5, because if I were to solve those linear factors, I would have -5, and I see -5 is equal to 0. And like I said before, if I set the y as 0 and set those factors equal to 0 and solved, I would get -5. We also see from this graph a turning point in the center here. This -3, -4 would be our turning point because it's where it dips down. And then you can see that it starts to go back up, and our second 0 would be the -1, 0. So when I go to graph this, it's important to see that turn and graph those points, so you see how the graph is symmetric. So when we set up our x and y axis, we know that we need to go as low as -4 and maybe as high as +5. So we could put the x-axis right in the middle. As long as I have 4 below and 5 above, I'm good. And the y-axis goes as far over to -6 and only to 0 on the right-hand side. So I'm just going to move my y-axis to the right of center. And now we can graph those points. So we have -6, -5, -5, 0, -4, oh, I graphed that first point wrong. Whoops. Try again. Okay, so -6, +5, -5, 0, -4, -3, -3, -4. There's our turning point or our vertex. -2, -3, -1, 0, and 0, 5. Now, I didn't give you a domain today, so we're going to draw the parabola curve with arrows on each end to show that it would continue in both directions. And there we have our graph. We can notice that our zeros on the x-axis are -5 and -1, as we said they'd be from the equation. So those are what we call the roots, or the zeros, or the linear factors. We also have our vertex, which mine looks a little funky, but it should be right there. That should be where it's the lowest. It's a minimum vertex because it's at the bottom. And it's at point -3, -4. And that also gives us our axis of symmetry, x equals -3. So from here, you're going to try the next problems on your own, answering the questions in the Go formative as you go. Be sure to ask me for help if needed.